Can sodium-ion batteries overturn the dominance of lithium-ion batteries? Here is the soulful singer who takes you on a great voyage of knowledge to talk about science. Remember to like and follow. Status of the lithium-ion battery industry. Since Sony first commercialized lithium-ion batteries in 1991, the status of lithium-ion batteries has gradually risen as fast as it has. However, there is currently a huge crisis in the lithium-ion battery industry. Demand-wise, the past few years have seen the growth of new energy vehicles as well as large-scale energy storage gaining momentum around the world, and these have led to a multifold increase in demand for lithium-ion batteries, and the demand is not declining at all. On the supply side, lithium is not abundant in the Earth's crust and is extremely unevenly distributed. According to the USGS in 2020, global lithium reserves are concentrated in 3 countries, Chile, Australia and Argentina, which together account for about 75% of the world's lithium reserves. Embarrassingly, although China is the 4th largest lithium reserve country, more than 85% of lithium resources are distributed in the western high-altitude mountainous and Salt Lake areas, where there are problems of low-grade lithium resources, difficulty in separation and high mining costs. Therefore, 80% of China's lithium resources rely on imports. Under the influence of the above factors, the price of lithium metal and lithium-ion battery-related raw materials such as nickel, copper and cobalt has been climbing. Data show that the price of lithium carbonate rose about 67% from the beginning of the year. The price of lithium hydroxide rose up to 80% from the beginning of the year. With smaller reserves and surging demand, the supply of lithium resources is becoming increasingly tight. For China, the development and cost of lithium-ion battery-related industries are constrained by the supply of lithium metal upstream, so we may also face the situation of lithium resources stuck in the neck. With the energy density of lithium-ion batteries approaching its theoretical limit and the safety concerns of lithium-ion batteries, the search for alternatives to lithium-ion batteries is on the agenda. As a result, sodium-ion batteries have become an option. History of sodium batteries. Of course, sodium-ion batteries are not an entirely new route to battery technology, and in the 1970s and early 1980s, the development of sodium-ion batteries proceeded in parallel with the development of lithium-ion batteries. However, as it became clear that lithium-ion batteries held greater commercial promise with their higher energy density, low self-discharge and long cycle life, interest in sodium-ion batteries declined. However, as we move into the second decade of the 21st century, sodium-ion batteries are once again beginning to be taken seriously as the demand for raw materials and cost of lithium-ion batteries increases. Principle of operation. Similar to lithium-ion batteries, which rely on the migration of lithium ions within the cell to achieve charge and discharge, sodium-ion batteries are charged and discharged by the reversible migration of sodium ions between the positive and negative electrodes. But what are the advantages of sodium-ion batteries? Firstly, there are abundant reserves of sodium. Sodium is the 6th most abundant element in the Earth's crust, with a reserve of 2.36%, about 1,000 times that of lithium, and it is more evenly distributed and less expensive to extract and purify. Secondly, the cost of sodium-ion batteries is lower than that of lithium-ion batteries. In contrast to sodium-ion batteries, which use little or almost no rare metals, the element cobalt in lithium-ion batteries is a metal with limited geological reserves and an unstable supply chain centered on a few countries. In addition, sodium metal does not alloy with aluminium, which allows the use of cheaper aluminium metal as a component material. Secondly, the electrical conductivity of sodium salts is higher than that of lithium salts, so sodium-ion batteries can use lower concentrations of electrolyte to reduce costs. Thirdly, sodium-ion batteries are safer than lithium-ion batteries. According to the preliminary high and low temperature test results so far, sodium-ion batteries have better high and low temperature performance. Overcharge, overdischarge, short circuit, pinprick, extrusion and other safety tests can be successfully passed, not easy to start a fire and explosion. When people use lithium-ion batteries, improper charging or high ambient temperatures can easily lead to spontaneous combustion and explosion. As you can see, sodium-ion batteries have the main advantages of low cost and high safety. Does this mean that sodium-ion batteries will overturn the dominance of lithium-ion batteries? Please give this video a like and follow me at this point. Next, let's talk about the shortcomings of sodium-ion batteries. 1. The energy density of sodium-ion batteries is lower than that of lithium-ion batteries. In the periodic table of elements, lithium is ranked 3rd and sodium is ranked 11th. Therefore, the relative molecular mass of lithium is less, which corresponds to a higher energy density of the battery. At present, the average energy density of sodium-ion batteries is 100-150 Wh/kg, while that of lithium-ion batteries is 150-250 Wh/kg, which results in lower range and greater battery weight for sodium-ion batteries. As we all know, battery range is the key factor for new energy vehicles to replace fuel vehicles. Low energy density means low range, and large battery weight is not conducive to the development of new energy vehicles. The result of this is that sodium-ion batteries are now more often used in low-speed vehicles, base stations or energy storage, where the energy density of the battery is not so high. 2. The charge and discharge efficiency of sodium-ion batteries is lower than that of lithium-ion batteries. The ionic radius of sodium is higher than that of lithium, so the shuttle of sodium ions between the electrodes is more sluggish, which affects the charging and discharging efficiency, resulting in low energy density utilization of the battery and a rapid decrease in energy density after multiple charging and discharging, while the temperature control of the battery may be more difficult. 3. The cycle life of sodium-ion batteries is lower than that of lithium-ion batteries. This means that the number of times a sodium-ion battery can hold up to charge and discharge is shorter. According to information, lithium-ion batteries can be charged and discharged more than 3,000 times, while sodium-ion batteries can only exceed 2,000 times. For at the beginning of the industrialization of sodium-ion batteries, the cost is still higher than that of lithium-ion batteries. Although the above mentioned, due to the characteristics of sodium ions, sodium-ion battery raw materials bring lower costs, but this is the result of industrialization. At present, due to the immaturity of the process at the early stage of industrialization and the inability to scale up mass production, sodium-ion batteries do not have a price advantage for the time being. Xingyu Kun, chairman of Ning Times, also said that the company's new sodium-ion batteries may be more expensive than lithium-ion batteries. If sodium-ion batteries want to be more cost competitive, it is necessary to develop a sodium-ion battery system with high energy density and low-priced auxiliary materials to further reduce the production cost of sodium-ion batteries. Summing up, comprehensive above, we know that sodium-ion batteries are not able to crush lithium-ion batteries. Although it has abundant raw materials, low cost and high safety, it is temporarily weaker than lithium-ion batteries in terms of energy density, charge and discharge efficiency, and life. For the time being, lithium-ion batteries will still be the first choice in the market, and sodium-ion batteries can be used as an effective technology reserve and supplement. The replacement scenario for sodium-ion batteries will be in the fields of partial energy storage, small power vehicles, short-range electric vehicles, backup power for power companies, etc. Okay, remember to point praise comments concern forward. Here is the Soul Singer Chat Science. I am the Soul Singer Jalun who take you knowledge of the great sea. No matter what, remember to point a praise and then go. Your support is the biggest motivation for me to persist. Thank you.